What's up, everybody? This is Aircrete Harry, and today I'm doing 20 different experiments with Aircrete. So a few weeks ago I did a foundation for a dome I'm building upstate New York. We're doing a monolithic pour Aircrete dome. The foundation was made of Aircrete, and I made a mistake when I did that foundation. I was supposed to use a lot less foam than I ended up using, which made the cement not strong enough to hold my screws. So the technique I'm using up there is an airform, and the airform gets bolted down to the foundation, and then that airform is filled with air pressure, and the air pressure is so great that it ripped the screws out of the foundation. So that foundation is still perfect for building a structure on top of. The issue is it did not have the strength to hold the screws in from being pulled out. So these are like the screws I was using in the foundation. What happened is the air pressure becomes so strong from holding the airform up, because that airform will hold the weight of cemented rebar. So even that extra weight on top produces even more pressure inside. And so the screws ripped out of the foundation. So the foundation wasn't strong enough to hold the screws down. But for compressive strength, to build a regular wall and everything on top of it, it's fine. It's just it wasn't strong enough to stop a screw from ripping out of it because of tremendous air pressure. So the test I'll be doing today will not only show me what the best mix will be for doing foundation, but I'm also taking it to the opposite end for very light and insulative. So today's test will involve using the standard Aircrete mix, which is a 194-pound bag of cement with 6 gallons of water. And the container you add the foam in can vary from 32 gallons to 50 gallons or 17 gallons. That part varies. But the cement to water mix will stay constant in these tests that I'm going to do. The thing that I will be changing is the amount of foam that I add to the system. So most people know of making Aircrete using either a 45-gallon or 50-gallon drum. What I'll be doing today is a smaller scale experiment. So I've taken the 94-pound bag of cement and I divided it by 20. So I'll be doing 20 different experiments using 4.7 pounds of cement with whatever the equivalent of water is. I believe it's 2.5 pounds of water. 2.5 pounds of water to 4.7 pounds of cement. That will be the constant. What will change is the amount of foam that I'm adding. So I'm doing ranges as high as a 200-gallon. So what that means is if you take 194-pound bag of cement and 6 gallons of water, you mix that in a 200-gallon container that I filled with foam, that's what that would be equivalent of. So it's going to be a very light, this is just a test to see how the Aircrete comes out being so incredibly light. And I'll be taking it down from that point. So instead of a 200-gallon container, now I'm going down to a 150-gallon container, to 100 gallons, to a 50-gallon, which I've done before, to a 40-gallon, 32 gallons, 20, and 10 gallons. So again, that is just, imagine I had all of those containers and all the sizes, and I'm adding the same amount of cement and water to them all. And I'm just changing the foam. That's all I'm doing with this experiment. So after that experiment, what I'll be doing is adding sand to the cement. And I'm just doing 4 different sand to cement mixes. So again, the cement and water ratio stays the same, but I'll be adding sand to it. So I'll be doing 3 bags of sand to 1 bag of cement, 2 bags of sand to 1 bag of cement, 1 bag of sand to 1 bag of cement, and a half a bag of sand to 1 bag of cement. So I'll be doing those different tests, and all of those tests will give me different compressive strengths. I won't be testing the compressive strength, but the test I will be doing is putting a screw into there and then pulling this screw out and seeing what kind of forces it takes. And I have a meter that I'll be using for that. So this is a pull push meter. So if I put this flat end here on the bottom, if you look at the gauge here, as I push, that'll move up, then it'll lock. And so the same goes for pulling. So I'll put a hook on the top part of it, right? We'll zero it out, and then I'll attach it to a screw somehow and pull it up, and we'll see how much force it takes to rip that screw out. So this is one of the tests I'll be doing today. Another test in the future will be actually for compressive strength. So I'm in talks with a local company now that does cement testing, where they test the compressive strength of cement on these 300-ton compressors. And so anyway, I'm discussing with them now pricing and all of that other good stuff. So hopefully it'll be really cheap so that I can do the test. And I'm talking to them about videotaping the whole thing. And so that's another test, hopefully in the very near future. So after I add the sand, and I'll be testing that cement using this tool, the other test I'll be doing is using this cement mix accelerator. So this has one main ingredient, which is calcium chloride. I've poured this into a 5-gallon bucket before and threw in Drexel, and I tried to make foam, and this will not allow you to make foam freshly added to the water. I let this sit in that same bucket of water overnight, then I added the Drexel to it, and I was able to produce foam. So since this is going to be helping the cement cure quicker, I'm thinking of adding it into the foam, because I'll have my foam bubbles, which will have the cement around it, which hopefully will cure quickly and keep my bubbles, my air pockets in the cement. So I'll be testing this out, and with this I'll be doing 1, 2, 3, 4, 5 different tests using this, and I'll be pouring all my test samples into these little buckets here that I got from the dollar store for $1. Anyway, and then I have one other test with some special white powder crystal that I'll be testing out, and if that works out as well as I heard it works, I'll be letting you all know what it is and how best to use it. So anyway, that's what I'll be doing today. So I guess from here there'll probably be a lot of fast forwarding. So this is my water. I have a mark here because I'll be refilling this obviously multiple times, at least 20. So that's marked out, and I'm gonna have to weigh the cement out because it's not easy to get a perfect level to see where the line is. I mean, I can guesstimate at 64 ounces, so I can put it in there, tap it, and if I'm a little under 64, I know I have approximately 4.7 pounds of cement in here. So I'm gonna throw this in a bucket. I'll see if this works. If this works, I'll be able to use this to mix all my cement. So this is going to be the control. This is just going to be what you saw, cement and water. So we'll see how that compares to adding foam in it. Okay, so this first one is going to require 9.6 gallons of foam. So I just realized I needed a bigger container to mix it all. So I'm going to fill this with foam 2 times, almost 2 times. Okay, so we have my Aircrete mix here. Got a lot of bubbles. It's not as uniform as it usually is, but with this amount of foam in there, it's I guess it could be expected to be like that. Okay, so our first test here is regular cement, which feels like it's getting warm already. This is super light. You see it popping. We'll see what that does. So much difference in weight between these two. Oh wow! Yeah, it's gonna be heavy. And look at all the water coming up on this one. Okay. Okay, so this is for the 100 gallon. I skipped the 150. The 150 is supposed to be 7.1 gallons. I went down to the 100 gallon, which is 4.6, which is fine. You see, some cement didn't mix as well as I wanted to. So that's not going to be as strong as it should be. There's cement that was still stuck in here that didn't mix well. So that's not going to be 100%. Okay, so the next is going to be 50 gallons. I'm going to skip right over the 7.1 gallon, the 150 gallon. So I did 200 gallon, and I went right to 100 gallon. So from there we're going to go to 50 gallon. So the 50 gallon requires 2.1 gallons of foam. So this is the mix most of you making Aircrete have made. 50 gallons to one 94-pound bag of cement. So this is going to be for a 40 gallon mix. So this 40 gallons. Actually, you know what? I'm going to skip right over 40 and go to 32 gallons. So this 32 gallon one, will take 1.2 gallons of foam. Okay, so this is about 0.6 worth of foam, which would be for a 20-gallon container. Again, this is if you were using a 94-pound bag of cement and you had a 20-gallon container, you would use 20 gallons of foam. And I just divided it down to 0.6 for the amount that I'm testing here. Okay, so I have my cement and water only, no foam. That's the control. Then look how much the bubbles have collapsed here already. This was the 200 gallons sample. This is the 100-gallon sample. Again, when I say 200 and 100, I'm referring to the containers, the bins you would use to mix the Aircrete up if you were going to be using it. For example, the idea behind this is for installation, and so we'll see how that cures and whatnot. So anyway, we have again control 200, 100, 50, 32, 20, and 10. So that's it for these. We'll let this cure. After it cures, after they cure, we'll screw this screw in, and then we'll do the pull test. Okay, that's it for this one. I'll get back to you on what happens. Next is I'm going to be doing the accelerator test. Peace out.